Okay, so what we want to do today is be able to convert from radians to degrees. And we've got a formula. So first of all, if we take a look at our two formulas, and I'm going to write them on the side. So one formula is, if we're going to convert from degrees to radians, our formula is theta over 180 times pi will give us our radians, okay? So in example A, we're just going to go, all right, theta is 80, that's my degree. Quinn, I know you're awake back there. We're just going to go 80 over 180 pi. And if you can keep things in terms of pi, it makes sense for us because it kind of relates us to the unit circle, right? So I can reduce that. Let's see, that's 18 over 180, which reduces to 2 ninths, right? 4 ninths. So 4 pi ninths, okay? Okay. Okay, now B, the problem with B is it's going to be difficult to make it a fraction. So we're going to end up just getting a decimal. And that's okay because we think about, like 3.14, which is pi. So it's okay to have decimals. We just have to know, we have to remember that this number is an angle. Okay, that's what's really hard about getting the whole radian thing is you got to remember this is an angle. Okay, so first of all, 36 over 60. I'm going to change this to a decimal. Okay. So it's like 36 minutes out of 60. So if I divide, it should be 0.6, but let's check it out. It is 0.6. So this is 0.6. So what I really have is a 48.6. All right. So then I'm going to use my little formula. I'll go 48.6 over 180 times pi. And this is a great example of something that won't really reduce. So we're just going to get a decimal answer. I'm going to use my calculator. We'll round to the nearest hundredth, all right? So I'm just going to go 48.6 divided by 180, divided by 180 times my pi, and I get an answer, about 0.85, okay? Yeah.
Hit the math button and then frac.
There you go. You can, you're right, yeah. So this is an angle in radians, and it's about 48 degrees 36 minutes. That's all. This is an angle. That is an angle. It doesn't look like an angle. It looks like a decimal, but it really does represent an angle. Think about the unit circle, right?
Can you move it up a little bit so we can... Oh, that's 36. That's
Yeah.
nice.
Okay, now, convert the other way. So we have our other formula. It's just 180 over pi times your degree gives you your radian. Okay, that's our other formula. And that's if we're going to go from degree to, radian to degree. And I wrote that down wrong, but that's okay, I can fix it. I can fix it. Radian equals a degree, there we go. So let's take our 180 over pi. We're going to multiply it times 3 pi fifths. So we're going to go from a radian into a degree. So we'll get, let's see, the pi's cancel, right? 180 times 3 divided by 5, I get an answer about 108. So about 108 degrees is the same thing as 3 pi fifths. Now with B, we're not going to get any pi's to cancel, so we will get a decimal, all right? So we're going to take our 4.5, and we're going to go ahead and multiply that times our 180 over pi. Okay, we're just using our formula. Kind of did it backwards. It's okay, it'll work for you. So I'm going to go, and Rosa, if you want to get notes, I think I've got them over there, okay? Yeah, I've got notes over there, you girls. So let's just use our calculator. I'm going to go 4.5 times 180 divided by pi, and I get about 257.83, but I want it in terms of minutes. So what I'm going to do is convert it. Okay, so it's really pretty easy to convert. I'm just going to take this decimal and multiply it by 60, okay? I'm just going to take this decimal and multiply it by 60. So in my calculator, check this out. See how smart we are? What if I just went minus my 257, right? There's my decimal. See, I'm just doing this for accuracy. So I got rid of the degree part, left the decimal, because then I can multiply that by 60 and get some pretty good accuracy, right? And if I round that up, it's about 50 degrees, all right? So my answer would be about a 257 degrees and about 50 minutes, okay? So I just converted my decimal into a degree by multiplying by 60, right? Okay, example 3, find the arc length. Okay, now if it's given in terms of degrees, there's two ways to do this. One, we could convert it. We could convert it to radians and use this formula. Or I gave you a nice little formula that's already got the conversion in it, which is nice. Let's use the formula that's got the conversion already in it. So if we want the arc length, we're going to go S equals, and our formula is theta over 180 pi r. So we're going to go S for arc length is just 40 over 180 pi times 10. Now in this case, I'm not going to have it in terms of pi. I want an answer. I want a real answer so I can measure it right. In terms of pi, I wouldn't be able to go to the hardware store and get an answer right. They look at me like I was crazy. I'd say I need it to be 3 pi centimeters long.
Get a calculator.
Yeah. So I'm just going to get the answer. I'm just going to go, okay, what is 40 divided by 180 times pi times 10? And my arc length is about 6.98 centimeters. Okay. Hi, Julie. That's not that bad. Let me see what you got, Julie.
Mr. Johnson wants to know if we have an answer key.
Oh, not to that yet.
Okay.
No. Tell him I'll be over real soon, okay? Okay. Example 4. Same thing, okay? But this time, find the angle. So if I'm given an angle, an arc of 6 centimeters and a radius of 4, I could find the angle. So the angle could be either found in radians or degrees. The angle could be either found in radians or degrees. So you've got two formulas. One is this really easy little formula, but it would give you my angle in terms of radians, right? Or I've got this much bigger formula, which give me my angle in terms of degrees. Now I like radians. Degrees are for dummies, right? So let's use the easy formula, but we need to remember that the angle is going to be in terms of radians. So if you use our S equals R theta, it's this easy. We go 6 equals 4 theta. We divide. We got 6 over 4 equals theta, but that's 1.5. Now 1.5 is an angle. It is an angle, but it's an angle in terms of radians, right? Pretty close to 90 is my guess. And we could do the conversion if we want to. It's pretty close to 90. 1.5.
Do it.
Okay, I'll just do it real fast. I'm just going to go then 180 divided by 1.5 times pi, and I get an answer about, oh, nope, I'm not going to do that. I did that wrong. Yeah, times pi. Nope, 180 divided by pi. I got to have the right formula. Times my 1.5. Yeah, it's pretty close. Almost 90. It's about 86 degrees. About 86 degrees approximately. All right, how am I doing? Okay. Turn the page. Okay, example 5. Now we want to find the area of the sector. Okay, so the area of the sector we've got to use, and we got a degree, so we have to use that formula. Okay, because it's degrees. So I'm going to go, all right, area is equal to my theta over 360 pi r squared. I'm just going to use the formula. So area is 40 over 360 pi times 4 squared. And again, I'm going to give the answer as a real answer. I will not leave it in terms of pi because I went to the hardware store and I gave it in terms of pi. They'd think I was crazy. So anytime it's a unit, oh, maybe Marston's, I don't know. Well, anyway, 40 divided by 360 times pi times 16, right? So it's about 5.5, about 5.6, and that'd be centimeters squared, because it's an area, right? It's an area. And that'd be the area. Which, that's a fairly good answer. I could do it in terms of pi, but people would look at me like I was crazy.
Why don't you just divide that by time?
We could. Okay, example 6. Okay, now boy rotates a rock on a sling. So remember, like David and Goliath, right? He's going to slay the giant. So 15 revolutions every 10 seconds, right? So first of all, the angle, right? He's going to go 15 revolutions, right? But as it goes around the circle, it's traveling 2 pi, isn't it?
Well, how long is this string?
Well, we're going to get that. We don't, well,
Are we missing a part?
we're just going to get, yeah, we need to have a length, don't we?
See, I don't even understand.
All we're going to get is angular. We're not going to be able to get linear, are we? So we're going to have 30 pi is my angle, okay? And so that would be my angular speed.
It's 30 pies.
Yeah, but that's for every 10 seconds. If we need it per second, yeah, that's all we do. 30 pi divided by 10 means it's going to be 3 pi revolutions per second, okay?
Is that linear speed?
That's angular.
So now let's say the radius of the string is
Yeah, give me a radius.
15 centimeters.
Okay. So we got the same number. Give me a different number.
Let's go 20 centimeters.
How many?
20.
Okay, let's go 20 centimeters, okay? So then you're just going to take this, 3 pi, right, and times it by your 20. Does that make sense?
So then you got 60 pi.
60 pi is how fast it's going in centimeters per second.
Do you refer to it as 60 pies or 60 pi?
Either
Do you
way.
like the plural or it's just pi?
It's just pi.
So Dave, that is a
English
lot of
is such a weird
questions.
language.
Okay, so maybe we can change this a little bit. Let me stop the recording.
Out all of them.
No, I'm not going to take them all out. Okay, ready, set, stop.